Hello, this is Mr. Wu and welcome to our lesson on percent of change. I'd like to give a special thanks to Mr. Puente for teaching me about the number line strategies you're going to see here. So our essential question, how do you find a percent of change, decrease or increase, and what can it be used for? This is a really common problem in pre-algebra and one that can be sometimes confusing to understand initially. So let's look at a more visual model. Now in your books you probably saw some sort of a formula about finding the amount of change and dividing it by the original amount to get a percent in decimal form. And that's a great shortcut, but it can be kind of confusing to start there. So we're going to look at a number line. And a couple of things to remember about a number line is whatever is over here is less than whatever is over here. And on one spot of the number line, whatever is up here on the same point is the same as what's down here. So let's see how this works. So we have an original amount and a decrease, or minus a change, and a final amount. That makes sense. Whatever is here is greater than what's over here, decreased by that amount of change. The original amount we're going to call the 100% amount. That's what we start with. It's the full thing. We're going to take a percent change, a minus percent change, and we get a final percent, which is going to be something less than 100%. Okay, so keep that in mind. Again, whatever is over here is less than whatever is over here. Whatever is on the top is the same as what's on the bottom at the same point. Now this number line model represents a type of proportion. So cross products are equal. That might not make sense now, but think of it like you think of a proportion of two ratios. So this times this is going to be the same as this times this. Cross products. It's a way we solve proportions because they're equal. Okay, so let's look at a problem. Find the percent of decrease from 16 to 12 using the same model. Here's my original amount, 16, down to 12. 16 is greater than 12. This is my 100% amount. And this is unknown. I want to find the percent of decrease, so I don't know what this is yet, and I don't know what this is yet. Okay, we have enough information for cross products, so set cross products equal to each other. So 16 times n is going to be the same thing as 12 times 100, or 1200. A simple equation, divide both sides by 16, so n is equal to 75, or 75%. So there we go. There's our 75%. 12 would represent 75%. Okay, now our one last step, it asks for what's the percent of decrease. Not just 75%, but how much did it change? So we just simply subtract to find the percent change. 100 minus 75 is 25, or 25%. So that is a 25% change. So we could say from 16 to 12 is a 25% decrease. That makes sense. 75% is less than 100. We decrease 25%. 12 is less than 16. So that's basically our model, and we can use this to solve any kind of percent of decrease and increase problem. So let's look at some more examples. A percent of increase, we just do the opposite of what we did before. We have an original amount over here. We increase to a final amount by a change. This is the 100% amount. We add a percent change, and we get a final percent change. What to note here is this is going to be something greater than 100%, and that's okay. It's okay to have percents greater than 100%. It just means it increased. I have more than what I started with. Again, this represents a type of proportion, so cross products are equal. So let's look at an example. Find the percent of increase from 45 to 54. Okay, there's 45. I'm increasing. 54 is greater, so it goes on the right. This is the 100% amount. I'm going to add a percent change, and here's my unknown amount. Remember, whatever is on the right here is greater than what's on the left. Set cross products equal to each other. There we go. 45 times n is equal to 100 times 54, 5400. Divide both sides by 45. N is equal to 120%. I'm going to fill that in there. Okay, now the second step. These are all two-step problems. Subtract to find the percent change. 120 minus 100 is equal to 20. So that is a 20% increase, or a 20% change. So our solution here from 45 to 54 is a 20% increase. I increased 20%. 120% of that value is equal to 54. Find the percent of decrease from 20 to 17. So this is a decrease problem. Again, I'll go a little faster here. There's 20. There's 17. This is the 100% amount since it's what I started with. And here is my unknown percent. Cross products, 20 times n is equal to 1700. N is equal to 85%. There it is. Second step, subtract to find the percent change. 100 minus 85 is 15%. So from 20 to 17 is a 15% decrease. And you want to continue to practice with these and set them up as proportions. What you can also do is just say, when you write these out, you don't always have to use a number line. I can just say 17 over 85 is equal to 20 over 100. Okay, so you can set up your proportion the way you normally think of using ratios. The number line is a good visual model of why we do that, though. Okay, another one. Find the percent of increase from 50 to 65. There is 50. I'm increasing, so 65 goes on the right. 100% goes to 50, and there is my unknown. Cross products. 50 times n is equal to 6,500. Divide by 50, both sides. N is equal to 130%. Again, it's an increase, so my percent is going to be greater than 100. Subtract to find the percent change. 130 minus 100 is equal to 30%. So from 50 to 65 is a 30% increase.